I think I'm recording. You had asked about reflections, and there were four types of reflections. Reflection across the x-axis, y-axis, across the line y equals x, and across the line y equals negative x. So I've roughly sketched out what that looks like, and what I'm going to do is I'm going to write down some rules, but I'll also look at the pictures, kind of describe those rules. I'll do this a little bit fast because it's a YouTube video, but here we go. So we'll start with the x-axis, and feel free to pause it and write stuff down. But the x-axis. So if I pick the point, we'll go with 7, 3. So I'm just randomly choosing a point, but I'm going to pick the point 7, 3. I'll just use the same point for each of these. If I pick the point 7, 3, and I want to reflect this across the x-axis. The x-axis is the horizontal axis right here. What that means is that the horizontal axis, the x-axis, is the mirror. So if we look into the mirror, you should see a reflection on the other side of the mirror. So if you look into the mirror, you'll see a reflection in the mirror right in front of you. And it's going to be the same distance from the mirror. In an isometry, distance is preserved. So my point here is 1, 2, 3 away from the mirror, which means the reflection should be 1, 2, 3 away on the other side. Reflection is going to be at the point 7, negative 3. What ends up happening for all of these is if you're reflecting across the x-axis, the x number is going to stay the same, and we're going to take the opposite of the y number. My point was at 7, 3. After that reflection, it was at 7, negative 3. So that's the rule. That's without drawing it out like I did here. That's the rule. You leave x alone, take the opposite of y. If you're reflecting across the y-axis, so again, I'm going to choose the same point, 7, 3. This is the y-axis. This is my mirror. If I look into the mirror, I should see my reflection on the other side of the mirror. Since my point here is 1, 2, 3, 4, 5, 6, 7 away from the mirror, from the y-axis, the reflection should be 1, 2, 3, 4, 5, 6, 7 away on the other side. That distance is preserved in an isometry. So it ended up being from 7, 3 to negative 7, 3. That's, again, the y-axis. So the rule that we could use is that the y number stayed the same, but the x number changed when you're reflecting across the y-axis. It was at 7, 3, and after the reflection, it was at negative 7, 3. Negative 7, 3. So that's the y-axis. And that's the rule if you don't want to draw the picture. For the line y equals x. Now I'm going to try to draw this correctly. And I'm doing it fast, so I hope I keep that straight. That seems about right. Okay, so there's my line y equals x. Again, I'll use the same point, 7, 3. If I'm reflecting across that line, it's a little harder to just see, but I'm going to go across the line like that. Hold on one second here. Sorry about that. Okay. Again, reflecting across, it's harder to see just going across the line because it's at a diagonal. And so that's harder to kind of figure out exactly where it would end up by just visually looking at it. So I'm gonna apply the rule, or I'm gonna write down the rule, excuse me, and then I'll apply it so we can see what it looks like. What it ends up being is that we just flip-flop the numbers. X becomes Y and Y becomes X, and that's it. The one way that I remember this, you have notes, so you don't have to memorize it, is that since Y equals X, I just change them to Y equals X and X equals Y, and that's it. If we try that here, I had the point 7, 3, and if I apply that rule, I should end up at 3, 7. Let's see what happens here. So 3, 7, it's right there. Yep, that's directly on the other side of that line, y equals x. So that's how you apply that rule for reflecting across the line y equals x. The last one we have then is reflecting across the line y equals negative x. Again, I'm going to draw this correctly. Pretty good. Okay, there we go. And my point was 7, 3. I'm going to do the same thing. Rather than visually trying to figure out where it would end up over here somewhere, I'm going to write down the rule and apply the rule. This one is going to be similar in that we are going to be doing some flip-flopping, but we're also going to take the opposite of both of them. So that negative ends up saying that we're going to flip-flop y and x just like before, but we're also going to take the opposite of both of them. Not necessarily make them both negative, we're always taking the opposite. So if these were negative, they become positive. They happen to both be positive, 7, 3. So then it's going to become negative 3, negative 7. I'm going to plot that point. And yep, that is on the other side, like it's been flipped across that line. Those are the rules. That's how to apply those rules for reflecting a point across any of those axes or lines.